Hello students, let us discuss the doping level of transistor. You know very well, this is an N transistor. So this terminal is known as emitter. Look at the statement. Your emitting doping level greater than collector doping level and collector doping level greater than base doping level. So emitter is heavily doped. So it has large number of electrons. Heavily doped means, so this is a pure semiconductor emitter layer. If you add pentavalent impurities with the pure semiconductor material, you will have N layer or N-type material. So here more number of pentavalent impurities are added with the pure semiconductor, you will get N layer. Similarly, your base is slightly doped. Base is slightly doped means, so base is a P junction. So here trivalent impurities are added with the pure semiconductor so that it is producing P-type material. So we are adding only a little bit or little amount of trivalent impurities in the pure semiconductor. It forms a less amount of holes or a small amount of holes in the P layer. So it is lightly doped. What about the collector region? Or here it is N-type material. Collector is moderately doped. Moderately doped means the doping level lies between P layer and N layer. Look at the number of electrons here. It is more. Look at the number of holes. It is very less when compared to these two layers. But your collector is moderately doped. So this is the doping level of N, P, N layer or emitter base collector junction. So this is very important to understand the operation of a transistor. You know very well, whenever you join p-type material and n-type material, these electrons, it will try to occupy the holes, or there is an electron hole combination takes place. So because of that, there will be a depletion layer. So look at the animation. These electron, it will combine with the holes and it will form an insulating layer. It is happened, the same thing has happened in the PN junction. So here it is p-type material and n-type material. These electron, it will go to p region, it will combine with the holes, it will form an insulating layer. So this yellow color shows that it is an insulation, or this layer is known as depletion layer. Depletion layer is formed between PN junction. It is p-type and n-type. When you connect together, there will be a depletion region. So here n-type material and the other side is a p-type material. When you join together, there is a depletion layer or insulation layer. The next thing is the biasing of transistor. So what is biasing? So to operate a transistor as a switch or an amplifier, you have to apply a DC voltage to your transistor. So applying DC voltage or applying DC voltage to the transistor, certain DC voltage to the transistor is known as biasing. You know very well, the transistor is a two junction device. Two junction means N and P are meeting here. So this junction is known as emitter base junction, and here N and P type materials are meeting here. This junction is known as collector base junction. So for a proper operation of a transistor, this emitter base junction should be forward biased and collector base junction should be reversed biased. So you should keep this point in your mind. Emitter base junction always connected in forward bias and collector base junction should be connected in reverse bias. Otherwise your transistor, it won't be act as a switch or it won't be act as an amplifier. So this is emitter base junction and collector base junction. What is forward bias? N means negative, P means positive. Negative must be connected to negative. P means positive. Base terminal is connected to positive. This condition is known as forward bias. Now battery negative is connected to N, battery positive is connected to P. So it is forward biased. Emitter base junction is forward bias. Next, collector base junction should be reverse bias. N is connected to positive and P is connected to negative. So this collector base junction is connected reverse biased. So this is known as biasing of transistor. Thank you.